dimension. One is covering the research avenues using the traits of biometrics, and we have considered as many traits as possible with the expertise in the biometric fields of biometrics. And the other one is using the implementation of the same on the devices. So I will once again welcome wholeheartedly to all the participants, all the dignitaries, and all my official supportings from the JSS Science and Technology University in their absentia. And special welcome to our Deputy Registrar B.S. Haris sir for his kind support and being in this inaugural function of the first day of the online session. So we welcome you, sir.
Thank you, madam.
Now, a brief introduction of the speaker. The first speaker of this session is Dr. Surya Prakash, sir. Dr. Surya Prakash is currently working as an associate professor in the Department of Computer Science and Engineering, Indian Institute of Technology, Indore, India, where he has served as the head of the department between 2017 to 2020. Sir has received his PhD, MS and BTech degrees, all in computer science and engineering fields only, from Indian Institute of Technology, Kanpur, Indian Institute of Technology, Madras, and India and University Institute of Engineering and Technology, Kanpur, India, respectively. Sir research interests include image processing, computer vision, pattern recognition, machine learning, deep learning, and biometric security. Sir has published several articles in referred journals and conferences. Sir has also authored 2 books titled Your Biometrics, Localization and Recognition, published by Springer, and the second book is IT Infrastructure and its Management, published by Tata McGraw-Hill. Sir has become Sir Vishweshwarya Young Fellow, Faculty Research Fellow in 2019. Sir is serving as a reviewer of several international journals and been a member of advisory board, organizing committee, and technical program committees of several international and national conferences and workshops. Sir has also organized several special sessions in international conferences and short-term courses in the domain of computer vision, machine learning, and biometric security. And we are fortunate enough to attend one of the GAN program where Sir has organized and we were the participant of it. Sir, the session is yours. We wholeheartedly welcome you for the first session of the online, first week of the faculty development program. Sir, it's your session, sir.
Yeah, thank you, madam, for the invitation. It is always a pleasure to be part of your programs. So let me start now. I just request participants, if you have any questions, you can stop me at any point and raise your doubts. So don't wait for the till the end and then ask the questions. And also, I think don't try typing them in the chat box because it's very difficult to read and then answer. If you have any question, please unmute yourself and then directly ask. I think that will be better. Okay, so in this session, I will be talking about biometric recognition and towards in the first part of the presentation, we will be discussing about some basics of biometrics, different traits, their plus and minus attributes, and all that. And then towards the end, I will be trying to give you some brief overview of some of the challenges and the opportunities where the research can be actually undertaken. So, and in this presentation, I'm assuming that many of you do not have much background about the biometrics, so that is why I'm also covering some of the very basic things. If you know about biometrics, these things might be might be a bit trivial for you, but just for the sake of completeness, let us also discuss them so that the people who do not have any background, they can also understand what we are talking, what we are discussing here. So, what is the meaning of biometrics? So biometric basically refers to the metrics related to human characteristics and traits. So all of us, we possess some unique characteristics and some traits. Those traits or those characteristics can be termed as biometrics. And these characteristics, biometric characteristics, they can be termed as And these characteristics are actually unique. So they can be actually used to distinguish one person from the another. Some of the examples of these unique characteristics are given here. For example, face, fingerprint, iris, hand geometry, ear, palm print. There are so many attributes that we always, when we all have, and they are also unique up to quite extent for every individual. So they can be used for recognizing the people. So as in the list you see, there are some characteristics which are physically associated with our body. For example, fingerprint, face, or DNA, palm print. These things are physically associated with our body. So these traits, they are classified as the physiological traits. And there are some traits or the characteristics that we all have, which are in our behavior. Like for example, the way we sign, or the way we walk, or the way we speak, or also sometimes, I mean, the way we type in the keyboard. All these things are behaviorally associated with our body. So since these are also unique for every individual, they can be also used uh, for uh, for establishing the identity of the people. So all these traits that we have discussed in the previous slide here, they can be actually classified in these two types: physiological, if they are physically associated with our body, and behavioral, if they are in our behavior. And what is biometric recognition? So if you're using these characteristics and trying to recognize a person, then that is termed as biometric recognition. So this biometric recognition can be performed based on physiological or biological features, or it can be performed with the help of behavioral features. Now, whenever we are talking about biometric features or the biometric traits, we expect that these biometric traits or the characteristics are distinguishable. Like for example, if you're using face for recognizing people, we expect that face will be, distinguishable, or face will be different for different individuals. And another very important thing is that it should be repeatable. So when we are taking that, when we are capturing that characteristics multiple times, uh, we should be able to capture that. Right? So it shouldn't happen that there is a characteristic which is only available once, and then later when you come for it, it is not available with the body or in the behavior. So these are two important characteristics that any biometric trait or any biometric characteristic should have. And if any trait or characteristic uh, has these two things, then that can be used for distinguishing people or for recognizing the people. Okay, so we have so many examples, as you know, you have face, fingerprint, iris, in signature. I mean, there are so many traits. So when we are, when we are comparing these traits, then the question comes: what is an ideal biometric traits? What are the ideal characteristics of a biometric trait? So here we'll be discussing few of the very basic ideal characteristics that are required in any biometric trait. So the first and foremost is the uniqueness. So any biometric trait that we are using for, and whenever I'm saying any biometric trait, you can take the examples like face and fingerprint, so then it will be easy to understand all these points. So let's say we are considering face as a biometric, then it should be unique, right? If the trait that we are using is not unique, then obviously we will not be able to use it for the recognition. So any biometric trait that we are considering for recognizing a person, that should be unique. And second thing is that it should be permanent. It should be permanently associated with the person, right? So as I said, it should not be available for some time. It should not be available for the other time. So it should be permanently associated with the body. And the next thing is measurability. This is also very important because if you carry some unique characteristic, but if it cannot be measured, then it is of no use. So any biometric characteristic that we are going to use to recognize people, that it should be easily measurable. It should be easily measurable. And second, the next, also we need to see the performance when we are using a particular trait, how efficiently we are able to recognize the person. This efficient or efficiency that you are measuring, this could be in terms of accuracy, or in terms of speed, or in terms of the robustness of the technology. There could be several factors based on which we can recognize the efficiency of the biometric trait, but I think the most important is the accuracy. So we expect that any trait that we are going to use for recognizing a person, that should produce good recognition rate. Right? And along with that, speed and other things are also important, but the most important thing is the accuracy. If the system is very fast and if it is not accurate, then it is of no use. So accuracy is the most important factor, you can say. And another thing that is required in the biometric data is the acceptability. Right? So maybe sometimes you may find that there's something which is very unique with each individual, but the people are not willing to give it. Right? They're not ready to provide the data for that particular biometric trait. So then also it is not very useful. Okay. The next characteristic that is needed is the circumvention. How easy it is to imitate that particular trait. Right? For example, voice. It is very easy to imitate. So in circumvention, we try to understand for a biometric trait how easy it is to imitate that. So any ideal biometric trait should actually possess all these characteristics, but in practice, you will see that it is not very easy. So I mean, theoretically, we don't have any biometric trait which has actually all these characteristics. In some cases, you may find one characteristic is very strong, but others are not very strong. Right? As you can see in this table, it compares all these characteristics that we have discussed in the previous slide with respect to these different biometrics, like for example, fingerprint, face, iris, voice. So you see, in case of fingerprint, uniqueness is very high, but its permanence is medium, because sometimes for example, especially for the levelers or the people who are using their hand more, for them maybe after some time the fingerprint is not available. And similarly, it is not very easy to measure because you need a specific hardware for it. So for example, for face, we are saying that measurability is very high because we don't need any special hardware for it. Using simple camera, we can actually capture. So like that, you see in this entire table for different traits, some of the factors are very good, but some of them are not that good. And ideally, we don't have any trait where all these factors are available. Okay. This is a more detailed table. You have several traits listed here, and they have been compared in terms of the characteristic that we have discussed. In terms of cost and accuracy, also you can compare different biometric traits. So usually the cost will be maybe you can say in terms of the hardware that is required there, or whether you need a specific device for it or not. So you can see that like iris has a very good accuracy, but its cost is also very high. The reason is that you need a specific hardware for capturing it. Similarly, if you compare the face and fingerprint, in case of fingerprint, you find that the faces the accuracy is more in case of fingerprint as compared to face, but the cost for both of them is roughly same. Okay, so like that, you see wherever you have a specific requirement of the hardware, and if the hardware is costly, then its cost will be more. So whenever you are like looking for a biometric, you need to see both these factors. What is the cost of the system, and similarly, what is the accuracy, and then there is a trade-off, and you need to select based on your requirements.
Sir, what is the
Uh,
difference between retina and iris?
yeah, so iris is like so I don't have example, but in retina, so in iris, I mean, sorry, in the eyes, iris is the textural pattern that you have around the black portion of your eye, right?
Okay, sir. Okay, sir.
Yeah, and retina is, I mean, in the so eye contains actually multiple parts. So in case of retina, you are using the characteristics of the retina. In case of iris, you are using the textual pattern. Okay, so they are different actually.
Okay, sir.
Is it? You can also compare the biometrics in terms of whether they are obtrusive or they are non-obtrusive. Like for example, how easily you are like able to capture them or analyze their patterns. For example, you see some of the obtrusive biometrics here, and some examples of the unobtrusive biometrics are here. Okay. Now, the very basic question actually comes whenever we are talking about biometric recognition, that why do we need biometrics? So as we discussed, that biometrics is required to recognize people, or with the help of biometrics, we can recognize people. But at the same time, we also get this question in mind that there are so many other ways of recognizing the person. Like, for example, you can recognize the person based on the ID card that person is carrying, or the smart card the person is carrying, or the computer can even recognize the person based on the password, or it can recognize the person based on the PIN. So why do we need biometrics for recognizing a person? So you see that there are some issues. These ways that we see here, they are actually called the traditional ways of recognizing a person. And in these traditional methods, we see that there are some limitations. For example, if you're relying on let's say ID or the password, then ID can be ID or password. They can be forgotten. Maybe you forget to carry your ID card, or you may forget your password, right? Or similarly, if you are using PIN or password, they can be cracked. Somebody can guess your password. Like, for example, one analysis shows that ABC123 is like a very popular password. So people can guess your password, right? Or maybe if they see the characters that you are typing, based on that they can guess your password. So there are some limitations in the traditional ways of recognizing people. So there is an alternative that is provided by the biometric based recognition, and all these limitations that you see here in traditional biometric traditional recognition methods, they can be actually very easily overcome. For example, these characteristics are considered to be very unique, so very easy to distinguish people. And biometric characteristics are actually in your behavior and in your body, so you don't need to remember to carry them. You are always carrying them, right? You can never forget your fingerprint or face to carry. So you don't need to, make any special efforts to carry your biometric, like you need to carry your ID card and the password, ID card, or you need to remember the password. And similarly, up to quite extent, these characteristics are easy to imitate. We cannot say that we cannot imitate the biometric characteristics, but they are difficult to imitate. Right? There are studies where fingerprint systems are attacked with the help of a spoof fingerprints and all that. Voice can be very easily imitated, but it's not as easy as let's say uh, cracking the password, or using someone else's ID card. Right? So it is difficult to imitate, and physical presence is required. So I mean, like someone else can carry your password, and then someone else can use your password to use the system. But in this case, if your system is recognizing you with the help of your biometric characteristics, then you need to be physically present there, right? No one can actually imitate you easily. So these are some good points about the biometrics, and many of these limitations that we discuss here, they can be very easily overcome with the help of biometric recognition, and that is why there is an interest in using biometrics for recognizing people. Okay, so now let us understand what is a biometric system, what are its components. So whenever we are using any biometric system, there are two steps involved in the process of its use. First is the enrollment, and second is the authentication. So whenever you are going to use any system, first you have to tell the system about yourself. So that is called the enrollment. So one time you have to go and register your fingerprint or face or iris with the system, and then when you go next time, then you can actually authenticate yourself with the help of the data that is being stored in the systems. For example, you want to use, let's say, ATM with the help of your fingerprint. So first you have to go to the bank and you have to register your fingerprint with the bank. And then next time when you go to ATM, you can actually use your fingerprint and then withdraw money with the help of your fingerprint. Right. So first you have to enroll, and then you can authenticate yourself. In authentication, we talk about two things. One is the verification and another is the identification. So let us understand them here. So in case of verification, actually you go to the system, you tell that you are so and so, and the system actually tries to verify whether the claim that you are making is correct or not. Right. So for example, if you go to ATM and then you say that your account number is, let's say, 1356, and then you present your fingerprint, then system checks actually your fingerprint against the fingerprint that is stored in the system against this account number, and then it verifies whether the fingerprint that you are supplying and the one that is stored in the database, it is same or not. Right. So here, in the process of verification, when the two biometric traits are being matched, here the comparison is actually 1-to-1. So one fingerprint you provide and another fingerprint is already there in the database. These two fingerprints are actually matched to tell whether the claim is correct or not. So this is always, this involves 1-to-1 comparison, and the verification outcomes are yes or no, or you can say the true or false. So the system will tell whether the identity that you are claiming is correct or not correct. So it's like the system will reply either yes or no, or it will say that your claim is true or your claim is false. Okay. So this can be actually used to confirm or deny a specific identification that is claimed by a person. Okay. Important thing here to note down is that this is a 1-to-1 comparison. It doesn't require multiple comparisons. In the case of verification, in the case of identification, we see that it involves one-to-many comparison. So here you will supply one biometric, and then this biometric will be compared with several other biometrics or the images, biometric images that are stored in the database, and then system will actually tell your identity. So here in the identification, we are posing a question like this, that who am I? You are supplying your identity. So you are supplying your biometrics and then trying to find out who you are, right? Or maybe you can pose it other way, like you have the biometrics of someone, let's say from the crime scene, and then you are trying to find out who is that person. So what you have to do, you have to capture the biometric from the crime scene, and then you have to match it in the existing, match it to the existing images that you have in the database, and then you have to establish the identity. So here, the comparison is one-to-many. And what are the outcomes of the identification process? So here you will get the identity of the person in return. So you're comparing this biometric with other available biometric images here, and then if there is a close match, then you can actually say that this particular biometric belongs to this person, and then you can actually establish you can find out the identity. So in summary, so in case of verification, you are supplying, let's say, biometric data to the system, and it based on the identity that you are claiming, the system will match your supplied data to the available biometric data in the database, and then tell you whether there is a match or there is no match. And in case of identification, you are supplying your biometric data, and this data is being compared with all the biometric images that are available in the database, and then the final outcome is the identity of the person. So if this output of this, let's say process is test 1, 2, 3, this means this biometric belongs to person test 1, 2, 3. Okay. Now, whenever we are using using any biometric characteristics, one is the biometric data that you directly capture from the body, for example, face data or fingerprint image or iris pattern, right? This is the data that you directly get from the person. Like you see some examples here, you get fingerprint image or voice sample or face. Then when you are storing this in the computer, you basically don't store this data directly in the system. You extract some unique features from this data, and you store those set of features in the database. So let's say from a particular biometric data, you get this feature or these features or this feature set. Then this basically defines a template for that person. So we can say that in place of storing the biometric data directly in the database, we are storing actually the templates, which are consisting of some unique features that are extracted from the biometric data that is being supplied. And so if you are supplying your biometric data at the time of enrollment, then you basically store enrollment template, or you can call that data that template as enrollment template. Or if you are using the system at later point of time, and you're fetching the template from the database, you can say that is the match template. This slide shows in more detail different components of a biometric system. So you see the first and foremost component of any biometric system is the sensor. With the help of sensor, you capture the data, and then the biometric system does some processing, pre-processing. For example, improving the quality of the image or removing the noise and all that. So some pre-processing is being carried out here. And then once the data is available in good shape, then we extract some features from it. And with the help of these features, as I said, we generate a template. And this template is, if you are in the enrollment process, then that template will be stored in the database. If you are in the verification process, then you will supply your identity, or you will supply, let's say, the identity that you are claiming. Against that identity from the database, the biometric will be made available into this matcher. This matcher will take the biometric that you are supplying at this moment, and then the one that is stored in the database, and then it will match and then tell whether the identity or the claim that you are making is acceptable or it should be rejected. So these are the components I just said: sensor, with the help of which you will be acquiring the biometric data. The feature extractor will tell you give you give you some features, and then matcher will tell you whether the two fingerprints are matching or not, and then you will be storing the data in the database if you are in the enrollment phase, and you will be taking the data if you are in the verification phase. You will, and these are samples you can see with the help of images. The sensor, with the help of sensor, you are capturing the image, and then you are doing some pre-processing to improve the quality of this image, and then from there, let's say you are extracting some unique points in the fingerprint. So this is called the feature extraction. Once the features are extracted, then the two fingerprints are being matched here. That is happening in the matcher, and for matching, you may be taking the data from the database, or if you're in the enrollment phase, you might be storing the data in the database. Okay, so we can actually, when we are using the biometric system, we are based on the single fingerprint image, we cannot actually say to whom that person, to whom that fingerprint image or that biometric data belongs to. So for that, we always need a reference fingerprint image that is known to belong to person XYZ, for example, in order to make this assessment. So we are always recognizing a person, because if you want the system to establish the identity, we have to first store the data in the database, and then only it can be used for the future use. So here you can say that we do not necessarily want to get the identity, but what we want is to recognize a person, right? And for that, you need to first enroll your biometric data with this with the device or with the system, and then only you can actually make use of that for the recognition. Sometimes we use one biometric characteristics, and there are instances where we can use multiple biometric characteristics for recognizing a person. If you are using multiple biometric characteristics, then the system that you use is called a multimodal biometric system. So for example, in this example, you see for establishing the identity of the person, hand geometry, face, fingerprint, all these three are, let's say, used. So this becomes a multimodal biometric system. And whenever you are using a multimodal biometric system, then you will be basically fusing. You will be performing some kind of fusion, right? And there are different ways of fusing the things. So let us discuss them very briefly here. So one type of fusion might be a feature level fusion. In this kind of feature level fusion, you have multiple biometric images, and then from there you are extracting the features, and then you are just merging those features or concatenating those features to make a let's say a bigger feature vector, and then with the help of that you are recognizing. So if you are doing that, then you are basically using feature level fusion. The fusion could be at matching score level. So where, and in all these cases, since we are talking about fusion, this is all true for multimodal biometrics, where we are using multiple modalities. So in case of fusion, which is at matching score level, in this case, you have multiple biometric images, and you have different matches. And with the help of those matches, you have got some matching scores. And then to take the final decision, you are basically matching all those scores, and then based on that aggregated score, you are taking the decision. So here, multiple matches will be producing different scores, and then you will be actually matching those scores, and then will be producing the final score to take the decision. In case of decision level fusion, every individual matcher is actually taking a decision. So let's say you are claiming you to be you to be someone, then every matcher will tell whether your claim is correct or not. So every matcher will return yes, no. In the previous case, it was returning a score. It was not saying yes, no. It was returning a score. All the scores were aggregated, and then based on that, the decision was taken. So yes, no decision was just coming based on the aggregated score, not based on the individual score. But here, this at the decision level fusion, if you have, let's say, n matches, every matcher is telling it's a decision, and then you apply some way to aggregate that decision and then take the final call. For example, you could apply majority vote. So you have, let's say, 5 matches. Let's say 3 are returning true and 2 are returning false. Then based on majority, you can say that the identity claim is true, and vice versa. Okay. So fusion, when you are talking about the fusion in the context of biometric, this could be different type. It could be done in different ways. You may have single biometric multiple representations, or you may have single biometric multiple matches, or you may have multiple biometric fusion. Let us see their details. So what we have in case of single biometric multiple representation. So you can understand this with the help of this example. For example, you have one fingerprint, and then you are extracting different types of features from it. So image is only one, but you are applying different types of different ways or different techniques to extract the features from this image, and then you are actually performing the matching based on those representations, and then you're taking the decision. So obviously you are going to have different matches here. In case of single biometric multiple matches, again, you can understand this with the help of this example. So you have, let's say, one fingerprint. So you get one feature set. Now, same feature set is actually used to use in different classifiers. So you extract some from one fingerprint, you extract one type of feature, but then the same feature is fed to different classifiers, and then you are fusing their decisions. In case of multiple biometric fusion, here you might be having multiple scores obtained from the multiple biometrics, and then you might be fusing them. So in this case, maybe you can say this is the most generic form. Here you have multiple modalities, like you might be using face, you might be using fingerprint, you might be using hand geometry all together. So that is the scenario here. And in the previous cases, you may have only fingerprint or only face, but you are creating you are using different matches because of the way you are extracting the features, or you are performing the matching. But here in this case, you have multiple modalities or multiple biometric modalities, for example, face or use of face, fingerprint, and iris. Okay, there are some other possibilities, for example, and all these possibilities are again dealing with the multimodal system. So here you may have you may store multiple templates in the database. Okay. So for example, you may have a fingerprint biometric system, and it stores multiple templates of a user fingerprint. So same finger, but let's say you are taking the multiple impressions, right? Yeah. So here, so we are saying that when a fingerprint impression is presented to the system for verification, it is compared against each of the template that is being stored in the database. Now these templates that you are saying here, they could be actually extracted from same fingerprint. I mean, one fingerprint you are extracting different templates, or you can also do what you see here, like you have let's say one fingerprint, and then you are acquiring actually multiple impressions from the same fingerprint. You are, let's say, taking 5-6 impressions, and then you are storing in the database. Okay, so there could be different possibilities for creating the multimodal biometric system. Now, when you have a system, you actually always want to know what is its performance, how well it performs when it comes to recognizing a person. So there are some standard metrics which are used for analyzing the performance of any biometric system. Some of them I have listed. There are a couple of others that I'm not discussing here. These are few which are actually often used and are important. So let us discuss them quickly. So false acceptance rate, false rejection rate, equal error rate, failure to enroll rate, and ROC curve. These are some popular characteristics which are used for evaluating the performance. So let me just tell you first what is FAR. So in case of, as the name suggests, you see this is false acceptance rate. So it basically measures how often a system falsely accept the claim of the claim. Right? For example, you are Rahul and you are claiming as a Ramesh. So how often such false claims are accepted by the system? So the rate at which the system accepts these false identities, that gives us the false acceptance rate. Let me just skip this because I think we don't have much time. In case of false rejection rate, what it does. So again, if you just analyze the name, you can very easily define it. So it says false rejection. So how many times are, what is the rate of rate at which the system falsely rejects the identity. So let's say you go to the ATM and you are claiming your identity and you are making a true claim, but system says that you are actually not the person you are claiming to be. So in that case, the system is actually falsely rejecting you. So the rate at which the system falsely rejects the claims, that gives us false rejection rate. Okay. These are few reasons why the false rejection rate happens. Let me skip that because we don't have much time. Another important the important feature that any biometric system should have is good enrollment rate. So this is actually measured in terms of failure to enroll. So how often the person the system is not actually able to enroll you with the system. So if let's say you have to give your impression multiple times, then only you are able to register yourself with the system, then we say that is not a very good system. So for a good system, failure to enrollment rate should be low. Okay. Another parameter that is very important uh, for measuring the accuracy of any system is the ability to verify. And this is the percentage of user population that can be actually verified the system. And this is computed based on this formula, ATV, which is 1 minus FT, which is a failure to enrollment rate, and then FRR, which is the false rejection rate. So the product of 1 minus FT and 1 minus FRR actually gives the ATV value, and this value we expect that should be high for a good system. There is a ROC curve which actually plots the values for false positive rate and true acceptance rate. So, and these values actually for a system are plotted for different thresholds. You can actually think about it. So whenever you are matching two people or two biometric feature sets, you will get a score. And based on the threshold, you will say whether the person is acceptable or not acceptable. The claim is acceptable or it is not acceptable. So you can imagine that as you make your threshold stricter and stricter, the false rejection will be more, false acceptance will be less. So similarly, you can see that when you are increasing the threshold from, let's say, low to high, you will see that there will be a change in false positive rate and true acceptance rate. So for a good system, we want that it should have low false positive rate, and at the same time, we want that the system should be true, should have true acceptance rate. So when we are plotting this ROC curve for different thresholds for a system, we expect that for a system, this plot should be close to uh, these two lines. Right? So we want that this plot should be as close to, or this would move to this direction as much as possible. Right. So for a good system, you can say that the plot will be touching this line here and this line here. So with the help of ROC curve also, you can find out how well the system behaves when it is identifying the people. Now let me skip these two slides and let me discuss a few challenges that we face in biometrics, and we can actually think about them and then try to do something there improve the performance. Right? So one of the very basic thing that we see in all this system is that or we try to see or try to analyze them is in terms of matching, how robustly they are able to match two identities or two biometric data sets. So for example, you see that when there is a pose change or when you have, let's say, the poor quality data as you see here, or sometimes you might be having very two similar people, maybe twins, and so how efficiently actually the people, how efficiently a biometric system is able to deal with these situations. For a good biometric system, obviously we want that the system should be able to handle all these situations. Right? Similarly, we want that the system should be robust to attacks. Like for example, there are different types of attacks possible. Uh, so for example, it should be robust to the presentation attack. For example, you are, let's say, presenting your fingerprint. This is the actual fingerprint you see here. And these fingerprints are the spoof fingerprints, which have been actually captured with the help of different kind of things. For example, wood glue or silgum, latex, for different materials. Actually, these fingerprints have been made, and maybe 3D model or 3D model of those fingerprints have been developed, and then based on that, these impressions have been captured. So a good system should have have the capability to handle these attacks. For different kind of biometrics, you may have different types of attacks. Like for example, in the face, you may have these different attacks. For the fingerprint, you may have these different types of attacks. For iris, you may have different types of attacks. And you see in this column, we see against these attacks, how robust is a particular biometric trait. This is an online tool available from the Michigan State University. If you want to actually try out, you can just try. This is for the presentation attack detection. Okay. Now, recently we see that there is some work in security and privacy of the biometric data. So whenever you are showing any biometric data to a person, or or when a person sees a biometric data, actually he or she can actually infer a lot of details about the person. Right? For example, if you see a face, you can find out what is the gender of the person, maybe what could be the age of that person, what could be the ethnicity of the person, and so on. There are a lot of things actually that can be actually obtained directly by viewing the data. So now there is a concern that we should have some privacy when you are providing your biometric data, right? So you can say you expect some security and privacy to biometric data. So there are some research where the people actually trying to attempt. This is a very good paper in this domain. If you are interested, you can go through this. So where people are actually trying to develop a system where when you give your biometric data, the system transform your data in such a way that it doesn't reveal your these kind of soft features. Okay. In terms of security, so like when you are storing your biometric data in the database, how secure your data is. You know that biometric data is permanently associated with the human body. So if you are losing it once, it is lost forever. So security of the data is very, very important. So there is a field of research in this domain. It's called biometric template security. Here, the people are trying to actually establish techniques which can transform your data before storing that in the database. And here, normally we are transforming the features. So when the features are extracted from your database, from your biometric data, they are not directly stored as it is in the database. They are transformed in such a way that the reverse mapping is not possible. That means from those features, the biometric data is not easy to generate. And then those transformed features are only stored in the database. So if you're interested, you can actually explore more about biometric template security. So as I mentioned, the privacy of the biometric data, I was just saying that whenever you see the face is basically face reveals a lot of things. For example, you see what is gender, what is the age, health, eyesight, ethnicity. So a lot of details actually you can actually find out from the image, right? So is there any way to hide these things, right? So in the slide that I showed you, I mean before, so there we saw that that paper was actually proposing a technique by which you can hide these details. You can provide your biometric data, but at the same time you can also hide these soft details. Another challenge that is posed is by noise. So obviously, you know that if the data is noisy, you cannot actually perform the biometric recognition very efficiently. So in this domain, the people are actually trying to develop techniques for improving the quality of the data or for improving the quality of the feature matcher, where severely degraded images or the features extracted from these severely degraded images can be actually considered. Okay. When you are talking about the 2D biometrics, where you are using 2D face and images, this is actually very much affected by the contrast and illumination. So people are advocating for the use of 3D biometrics, which are up to quite extent they are not affected by the contrast and illumination. Another challenge is actually posed in the biometric system when we are dealing with the huge biometric database, right? For example, in Aadhaar, you have billions of people actually registered in the database. So when you are searching their database, you need actually fast and efficient methods for the searching. So here in this domain, the people are trying to develop techniques for indexing the biometric databases or techniques for providing efficient or fast searches when we are doing the comparison. This is recently a new domain. So when you are actually providing your you might have observed when you are registering yourself with the mobile, you are actually providing your the mobile is a very small sensor, so you provide your partial fingerprint. So when you are providing the partial fingerprint, it is actually prone to be attacked, because when you are providing partial fingerprint, you have only limited features in that. So there is a domain where people have actually developed master prints. So they have shown that a master print can be developed which can match to many of the users, and then the system can be spoofed. So for example, this study shows that with the help of the 5 master prints, it was actually possible to spoof 26% users for this database. Similarly, for this database, it was shown that 65%, almost 65% users were actually were spoofed with the help of 5 master prints. So when you are developing any technique for the partial fingerprint, or when your system is using partial fingerprint for matching, you should be actually you should be very careful about developing your matcher. As this study shows that if you are using partial fingerprints, it could be very easily spoofed. There are other domains where the people are working. For example, continuous authentication. So if you have the biometric, let's say phone, smartphone, it has a lot of sensors. So you can continuously keep capturing the data from those sensors, and then you can actually recognize people. So here in this paper, if you just read, you will get more about the details of this technique. What they show here that with the help of, even without using your biometric data, by just analyzing certain patterns or your mobility, that is, let's say, captured with the help of your mobile, you can be easily identified. Right? So, for example, when you start your in the morning, you know that everybody has a very specific pattern of movement. So this paper shows that with the help of that movement, with the help of that pattern of the movement, the people can be quite efficiently recognized. There are also some researches going on in the domain of identifying the sensors. For example, you have an image captured, and then you're trying to identify from which sensor it has been captured. So like when you are performing the identity, maybe you can perform dual factor authentication. So you are supplying your biometric data and also your device is also being identified, which device you are using. So with the help of device identity and with the help of the biometric feature that you have provided, the data is data is used and you are recognized. For providing the privacy at the beginning, I said that you are transforming the image so that it doesn't reveal your true identity. So there are a few approaches. For example, in case of there's an approach called visual cryptography, where you are decomposing your fingerprint images into two random images. So when you are registering yourself with the system, you're not registering yourself with the true fingerprint image, but you are basically registering with these decomposed images that you are getting from this procedure. Right. So if you are having, let's say, the two images from a biometric data, you have created two samples, then the person can be actually recognized with the help of those two samples. And one scenario could be like one sample is stored in one server, another sample is stored in another server, and then the decision is taken collectively based on these two samples, right? So just remember here, you are not storing or using the actual face. From these actual face, you are creating those two samples from it, and then you are making the identity claim. So or you are performing the verification, and because of doing this, you are actually able to maintain the privacy of the data. There's another approach for maintaining the privacy. So it is called face morphing. Here you have, let's say you want to store the face of a person. You are not storing its true face, but you are morphing it with the help of this procedure and then storing. So what it does, so it basically creates a mixed up. You have two faces, F1 and F2, and then you are creating the mix of these two faces, and then whatever you are getting, that is being stored in the database. Right, so this is the procedure of progressively doing this transformation. And I was just mentioning these autoencoders, so they can be also used for maintaining the privacy of the data. This particular encoder that you're seeing here is actually for the face images. Yeah, so that's all. I think I've reached the end. These are the references that I've used for preparing this presentation. Particularly, I have used many slides from this presentation of Professor Arun Ross. So I want to acknowledge him. And these are the papers from where I've taken the data. So if you are interested in getting more details of these techniques, you can refer these papers. Due to lack of time, I could not explain many of these things in detail, but I think these are very good source of information. You can actually visit these papers and then get more details about all that I've discussed here. So with that, I conclude my talk here. Thank you very much. If you have any question, I will be really happy to answer them. So ma'am, we can take questions if there are any, otherwise we can go for the break.
Yes, sir. We'll have the break and you can continue after 5 minutes, sir, the next session.
All right, ma'am. Thank you.
Okay, okay. So I request participants to take a quick break of 5 minutes and sir will be taking up the next session exactly at 8 o'clock, 5 minutes, 8:05. And we have an exclusive discussion session from 9 to 9:30. I request all the participants to either intervene in between or keep all the questions for the discussion also. Any participants wants to know more about the teams that we have formed and the purpose of it, you can ask me now, or I shall brief as I've told in the mail. I can brief you again in the WhatsApp chat also.
Yes, ma'am. We want to know why was the group made, ma'am?
Okay, I'll quickly explain this. Actually, the ATTL this time has asked us to form these teams, and as you have seen in the schedule, the second week of the FDP has two sessions about discussing the important articles chosen in the domain of the FDP. So 2 articles have been shared with you all. So the team members has to go through the articles, okay, make a PPT of it by yourself. I mean, that is not of this week. When you come over here, it will be on the day 2 and day 3 that you have to present the gist of the article. That is why the team is formed. That is reason 1. Reason 2, the evaluation of the participation to avail the certificate goes with 4 different criteria. One is the individual marks is obtained by the attendance, then the weekend quiz that you take up, then the team presentation, and as you all know that we have a session for industry visit. So there is a mandate that once the industry visit is over, the team has to prepare 1-page report based on the industry visit, okay, and submit it on the last day. And even on that, the evaluation, that is 10% of the marks is availed based on that. So the team goes with the team evaluation goes with the 60% of the marks, and 40% of the marks is evaluated individually. And as you all know that whoever score 70% will avail the certificate, and 90% and above marks scored candidates or participants will avail the certificate with the distinction. The 20 best participants will get a prize on the last day in the validatory, the 20 best participants, and these are the criterias meant to choose the best participants. That is the attendance, participation, presentation, and the report that you give up.
Ma'am, the valedictory, is it on 16th, ma'am?
Yes, the valedictory is on 16th. The second test, that is the quiz, and the valedictory will be on the 16th. And on the 16th, only one session is there. The rest of all is these activities that you will be presenting the report of the industry visit. Okay, and then taking up a quiz, a very 10 to 20 question quiz of that week, and then the valedictory function, in which the best participants will be rewarded.